for B10A, in an experiment, small amounts of 3 transition metals, zinc, nickel, and copper were added separately to their metal nitrate solutions, and the results are shown. Okay, so now let's look at the table. When aqueous zinc nitrate is, when aqueous nickel 2 nitrate is added to zinc, your green solution turns colorless and a grey metal is coated with a silvery solid. Okay, this right is a metal reactivity question. So what do I mean by this, right? Let's look at zinc, nickel, and copper. Let's arrange them in terms of their reactivities. So we know that zinc is definitely more reactive than copper, correct? This is from your reactivity series, but I don't know how reactive is nickel. So when the concept behind metal reactivity is that a more reactive metal is able to displace a less reactive metal from its salt solution. Correct? So now, when aqueous nickel 2 nitrate is added to zinc, when zinc is added to aqueous 2 nitrate, correct? The green solution turns colorless. There is a change. So what does this indicate? It indicates that zinc is more reactive than nickel, correct? So zinc being more reactive than nickel is able to displace nickel from its salt solution, which is aqueous NiO3, NiNO3 correct? So that's why there's a change. The green solution, it will turn colorless. So this green solution refers to your nickel nitrate, correct? So it turns colorless because it has formed zinc nitrate. And a grey metal is coated with a silvery solid. Same thing, this grey metal is due to zinc, correct? And this silvery solid is nickel. So let's write the equation for this. So when zinc is added to nickel nitrate, okay, it will displace nickel from its salt solution to form zinc nitrate plus nickel solid, correct? So then now let's look at aqueous copper 2 nitrate. When zinc is added to aqueous copper 2 nitrate, blue solution turns colorless and grey metal coated with a reddish brown solid. Same thing, we know that zinc is more reactive than copper, correct? So zinc will be able to displace copper from its salt solution of CuNO3 2. So again, this blue solution is my copper 2 nitrate. Turn colorless, this is zinc nitrate. Then grey metal is my zinc coated with a reddish brown solid. This is my copper solid. Okay? So now when copper is added to aqueous zinc nitrate, there is no visible reaction. So what does it indicate? It means that copper is less reactive than zinc. That's why it is unable to displace zinc from its salt solution, correct? Then now when copper is added to aqueous nickel 2 nitrate, there is also no visible reaction. So same thing, this means that copper is less reactive than nickel. Okay, so the final order of reactivity would be copper will be the least reactive, followed by nickel, followed by zinc. Okay, so zinc is the most reactive and copper is the least reactive. Correct? So now part 1, they ask you to describe describe the observations expected when nickel is added to aqueous zinc nitrate and aqueous copper 2 nitrate. First, when nickel added to zinc nitrate, I know that, okay, this is the reactivity series, right? It's copper, nickel, followed by zinc. Nickel is less reactive than zinc, so would it be able to displace zinc from its salt solution? The answer is no. There will be no visible reaction. Correct? Because nickel is less reactive than zinc, hence unable to displace zinc from its salt solution, which is, in this case, is zinc nitrate. Okay? So, then now, when nickel is added to copper 2 nitrate. Okay? Nickel, I know that it is more reactive than copper, correct? So it is able to displace copper from its salt solution, which is copper nitrate. Correct? So what would the observations be? The initial color of copper 2 nitrate is blue solution. Correct? So I'm going to adopt the phrasing from here. Your blue solution turn to what color? Nickel would displace copper from its salt solution to form what? So this will be the chemical equation. Nickel plus copper 2 carbonate to form nickel nitrate, correct? Plus copper solid. So, copper 2 nitrate, I know that this is a blue solution. Nickel is what color? Let's see. Nickel is a silvery solid. So this is a silvery solid. Correct? Then now, nickel 2 nitrate is what color? Again, from the table, it is a green solution. So green. And copper solid is reddish brown solid. So if I adopt the phrasing in the table, right, I will say that blue solution turn green, correct? And a silvery solid would be coated with a reddish brown solid, which is your copper. Okay? So for part 2, give the ionic equation for the reaction between zinc and aqueous copper 2 nitrate. So same thing, let me start from the chemical equation. Zinc plus copper 2 nitrate, which is in the aqueous state. So because zinc is more reactive than copper, right, it will be able to displace copper from its salt solution to form zinc nitrate plus copper solid. So same thing, to form ionic equation. First rule is, those that's not in the aqueous state, I don't touch. So in this case is zinc. So zinc, I bring it down. Okay, anything else? Copper. Copper is in a solid state also, so I bring it down. Okay, then those that's in the aqueous state, I can break it down into the respective ions. Correct? So here will be 2. Same thing, here will be Zn2 plus and 2NO3 minus. So now let me write it down. Cu2 plus 2. Okay, then now I have to cancel away the spectator ions, which in this case is the nitrate. Anything else? Okay, so there's nothing else in common. So the final ionic equation would be zinc solid state plus Cu2 plus in the aqueous state to form Zn2 plus copper in the solid state. This will be my ionic equation. Okay. Then now for part 3, in terms of oxidation state, explain why the reaction in A part 2 is a redox reaction. Okay, so now let's look at the chemical equation again. Okay, never mind, let's look at the ionic equation. So same thing, sorry, Cu2 plus from Zn2 plus copper. Okay, let's write down the oxidation state. For zinc, the oxidation state is 0 because it is in the elemental state, correct? Then the product Zn2 plus, it has the oxidation state of plus 2. Okay, then Cu2 plus, oxidation state of plus 2 and 0. So, from plus 2 to 0, there is a decrease in oxidation state, correct? So this means that reduction has taken place. Whereas from 0 to plus 2, there's an increase in oxidation state. So this indicates that oxidation has taken place. So what does redox reaction mean? It means that there must be oxidation and reduction occurring simultaneously. Okay, so this is a redox reaction because, okay, now let's talk about the phrasing. So I say that zinc has been oxidized as the oxidation state of Zn has increased from 0 in zinc to plus 2 in my zinc nitrate. That's where the Zn2 plus ion come from, correct? So at the same time, your copper Cu2 plus has been reduced as the oxidation state of copper has decreased from plus 2 in copper 2 nitrate to 0 in your copper solid. Okay, so this is how you explain the redox reaction. So for part 3, they say 25 cm cube of 1 mole per dm cube dilute nitric acid was reacted with excess nickel 2 carbonate. So given that 2 moles of nitric acid is required to react to produce 1 mole of hydrated nickel 2 carbonate, which is NiNO32 from the equation above, calculate what is the percentage yield if 2 grams of hydrated nickel 2 nitrate were obtained at the end of the reaction. Okay, first step. I have the volume and the concentration of HNO3, correct? So the first thing I need to do is find the number of moles of HNO3, which is equals to concentration times volume. So the concentration is 1 mole per dm cube and the volume is 25 cm cube. But remember, I must always convert it to dm cube. Okay, so your answer would be 0.0250 mole. Okay, then the second step. They told you that 2 moles of HNO3 is required to produce 1 mole of your hydrated nickel 2 nitrate. Correct? So essentially they are telling you the mole ratio of HNO3 and Ni3 to 6H2O is 2:1. Correct? So if I have 0.0250 mole of nitric acid, what is the number of moles of nickel 2 nitrate? It is, I divided by 2, so it will give me 0.0 125 mole. Okay, so now I have the number of moles of hydrated nickel 2 nitrate, which is 0.0125 mole. Correct? I want to find the percentage yield. What is the formula for percentage yield? It's equals to the actual mass over theoretical mass times 100%. Correct? I know that the actual mass is 2 grams. But what is the theoretical mass? I don't know. So I need to calculate it. So to calculate theoretical mass, I'm going to use this equation, which is number of mole equals to mass over mR. So the theoretical mass would be the number of moles, which is 0.0125 times the mR, which is 229. So it should give me 3.6375 gram. Correct? Okay, then to find the percentage yield would be my actual mass, which is 2 gram, over the theoretical mass, which is 3.6375 gram times 100%. So the answer would be 54.98%, round up to 55.0%. 368. Okay, so this will be the answer. Okay, for B part 1, okay, hydrated nickel 2 nitrate can be produced by reacting excess nickel 2 carbonate with dilute nitric acid. So I have nickel 2 carbonate with dilute nitric acid. The resulting mixture is then filtered and heated to saturation, and green nickel 2 nitrate crystals is obtained by allowing the saturated solution to cool at room temperature. So for part 1, explain why is it necessary to add nickel 2 carbonate in excess to dilute nitric acid. This is your salts question, your salts preparation. Okay, so why is nickel 2 carbonate added in excess? It is to ensure that all the dilute nitric acid is reacted completely. Okay? Then for part 2, explain why nickel 2 nitrate were obtained by allowing the saturated solution to cool at room temperature instead of heating to dryness. Okay, this one, right? Look at what I'm trying to obtain. I want to obtain hydrated nickel 2 nitrate. Crystals, correct? I want to obtain hydrated. What does hydrated mean? It means that there is presence of water. If I heat to dryness, will I be able to obtain hydrated nickel 2 nitrate crystals? The answer is no, correct? So why do I need to allow the saturated solution to cool at room temperature instead of heating? Is because you can say if the solution is heated to dryness, you will obtain anhydrous, which means absence of water. So you either obtain anhydrous nickel 2 nitrate, or you can say that this one will decompose. Your nickel 2 nitrate will decompose. Okay?